The reason being that this is your third pivot, so since it's already at 0, you cannot go and add changes, so you can't add multiply by 1/2 or anything because it's already in this form, so you initially now only have 2 pivots. So now that you know what 2 pivots you do have, you're going to rewrite the equation. So what we have would be here at the x1, which is 1, 0, x1, and then in the second column, you're going to take these 2 pivots and go back to the original equation and use the 2 pivots that are here. Your 2 pivots, which is right here, and you're going to use these rows to denote how you're going to be making your parametric equation. So these 2 rows, because you have a pivot right here and right here, sorry, it's looking a bit messy, but the one is right, there's a 1 here and there's a 1 here for the 2 pivots because you cannot have a pivot in this third row because of the fact that you can't multiply anything to the pivot, so that left you with just these 2. So by doing the first row, you have x1 because it's denoted with the 1. There's no x2, there's an x3 of -4 is equal to the 7 that we had. Then as the second row, there's no x1, but there's an x2 and 1 is the coefficient, plus 2x cubed, 2x third, and minus 1x4 equals 6. So you're going to rearrange the problem, so it would be x1 equals 7 plus 4x cubed, or keep saying cube, 4x3, and x equals 6 minus 2x3 plus x4, because you move these over. And then the reason you know that you're going to have to make it into a matrix is because this is not unique, because there's no free variables. So now you have to write into parametric form, starting with the constants that we had at the beginning. So it'd be 7, and it'd be only 7, 6, 0, 0, 0. And then you're going to do x3, which is 4, -2, 1, 0, 0, and then x4, which is 0, 1, 0, 1, 0. And since there is 5 rows, it's in the form of a hyperplane, so that helps to finish our problem.